Hi all, welcome to Go Classes. In this lecture we will study a new group. This new group is multiplication modulo n. We denote this group using the symbol un. So we will do the complete analysis of this group. Let's start. In the previous lectures we have already seen this group, addition modulo n. This group we have already seen. If you remember, we have seen that you have Zn. What is Zn? Zn is basically all the remainders, all the possible remainders when you divide by n. So I can say this Zn, that is all the possible remainders when you divide by n. So I can say Zn is equal to 0 to n minus 1. So this is your Zn, and we have already seen that this Zn under addition modulo n, this is a group. This is a abelian group. We have already seen this. The complete analysis of this group we have seen in the previous lectures. So you can see this Zn. Zn means, what is Zn? Remember, Zn means 0 to n minus 1. This is your Zn. Or I can say, what is Zn? This is the set of possible remainders when you divide any integer by n. Okay, so these are the remainders possible when you divide any integer by n. These are the remainders possible. So I can say this is your Zn. We have already seen that this Zn under this addition modulo n, this is a abelian group. Okay, what is this operation? This operation is like this, that a addition modulo n b, that is equal to, first you do the addition and then you find the remainder when you divide by n. Then you find mod n. So this is the point. Okay, very simple. Now, this is a abelian group, we already know. Let's see this example. For example, you can see this Z4 addition modulo 4. First of all, what is Z4? Remember, Z4 means 0 to 4 minus 1. Means I can say 0, 1, 2, 3. This is your Z4. Z4 is set of possible remainders when you divide any integer by 4. So if I divide any integer by 4, then these are the remainders possible. So this is your Z4. Or I can say this Z4 is simply 0 to n minus 1, that is 0 to 4 minus 1, that is simply 0, 1, 2, 3. This is your Z4. Now, the operation is addition modulo 4. Addition modulo 4. This is your operation. So, let's see in this. First of all, for example, if I ask you, what is 3 addition modulo 4, 2? What is that? That will be equal to, remember, first you add. First you do the addition and then you find the remainder when you divide by 4. Means then you find the mod 4. So the answer will be, I can say 5 mod 4 and that is equal to 1. So very simple. Similarly, if I ask you what is 3 addition modulo 4 3, that will be equal to, first you do the addition and then you find the mod 4. So here your answer will be 6 mod 4, that will be 2. So similarly you can find, for example, if I ask you 2 addition modulo 4 2, that will be equal to 0. You can check it out. Similarly, if I ask you, for example, 3 addition modulo 4 0, what is that? That will be equal to 3. So very easily you can see this is your addition modulo 4 group. We already know that this addition modulo n, this Zn under addition modulo n, this is a abelian group. This we already know. This Zn 0 to n minus 1, this is a group under addition modulo n. This concept we have already seen in the previous lectures. Now the next thing that you might be thinking, can you multiply? See, what we have seen that this Z4 means 0, 1, 2, 3, this Z4, this is a group under addition modulo 4. Okay, under addition modulo 4, we have already seen that this is a group. This is an abelian group, we have already seen in the previous lectures. But you might be thinking, so here we have addition modulo 4, can I define multiplication modulo 4? Will that be a group? Means if I define multiplication modulo 4, will that be a group? Okay, so can I multiply? Can I define this multiplication modulo 4? Can I define this? So that is your doubt that you might be thinking. So that is the question. Can we multiply elements of Z4? Means, what about this? What about this structure? Look at this structure. Is this structure a group? Think about it. This Z4 multiplication modulo 4 means your base set. Remember, Z4 is this. Your Z4 is 0, 1, 2, 3. This is your Z4. And what is the operation? The operation is multiplication modulo 4. So if I ask you what is A multiplication modulo 4B, that will be equal to, first you multiply and then you find the mod 4. Then you find mod 4. This will be your A multiplication modulo 4B. Okay. Now I am asking, what about this structure? Is this structure a group? Is this structure a group? So let's check it out. So we have this structure. We are talking about this structure Z4, and Z4 is nothing but 0, 1, 2, 3. This is your Z4, and operation is multiplication modulo 4. I have already told you what is this operation. Remember, in this operation, A multiplication modulo 4, B. What is that? That is equal to, first you multiply and then you find mod 4. This is your operation. For example, if I ask you 3 multiplication modulo 4, 2, what that will be? First you multiply 3 with 2 and then you find the mod 4. So that will be equal to 6 mod 4, and 6 mod 4 will be equal to 2. Similarly, if I ask you 3 multiplication modulo 4, 3, that will be equal to, first you multiply. If you multiply, then it will be 9. Then you find mod 4. So that will be equal to 1. So easily you can do. For example, if I ask you what is 2 multiplication modulo 4, 1, what that will be equal to? First you multiply, then you find mod 4. So that will be 2. So first you understand this concept, that this is your multiplication modulo 4. So first you multiply, then you find the mod 4. Now, what about this? Is this a group? Yes, this is closure. See, closure property is satisfied. I can say closure property is definitely satisfied. Okay, because ultimately, if you notice, you take any two elements from here. See what will happen. You take any two elements from here. Any two elements you take from here. See, first you will multiply them. Then ultimately you are finding the mod 4. Ultimately, I am finding the mod 4. The point is this. You take any two elements from here, A, B, any two elements, they can be same or they can be different. Take any two elements, first you multiply, but ultimately I am finding mod 4. So you can see this final answer. Okay, this, I can say this final answer will be either 0 or 1 or 2 or 3. So you can see that ultimately closure property is satisfied. What about the associative property? What about this associative property? Associative property is also satisfied because this is very similar to multiplication. This is very similar to multiplication. So you can easily see that this multiplication mod n, this is associative. This is very similar to multiplication, and you know that multiplication is associative. Okay, so this operation is also associative because this is similar to multiplication. You just do the multiplication, then you find the remainder. Okay, so very simple. So this is also associative. Next, what is the next one? What is the identity element? Do we have identity element? Yes, there is identity element, that is 1. Because this 1 is the identity element for multiplication. Similarly, this 1 is identity element for multiplication modulo 4. So this 1 is the identity element, because you can easily notice what is A, this multiplication modulo 4, 1. What is that equal to? First you multiply them, and then you find mod 4. Okay, so whatever element you take from here, if you see the multiplication modulo 4 with 1, okay, if you take any element from here, this element A, this is 0 or 1 or 2 or 3. So you take any element from here, if you see the multiplication modulo 4 with 1, then that will be equal to A. So I can say identity element we also have. But what about inverse property? So you can see this structure is closed, closure property is satisfied, this structure is associative, and this structure also has identity element. Identity element is 1. Now, what about inverse property? You can see this structure does not have inverse property. This structure, it does not have inverse property. There is no inverse property. No inverse property. Why there is no inverse property? Because you can easily notice that there is no inverse of 0. For example, you can see, what should I write here? Okay, let's find out the inverse of 0. Let's find out. Means what should I put here such that I get the identity element? What should I put here such that I get identity element? The answer is this does not exist. This does not exist, because whatever you put, see 0 multiplication modulo 4 A, that basically will be equal to 0 mod 4, and that will be basically equal to 0. So you can see 0 inverse does not exist. There is no inverse of 0. Similarly, also you can notice here that 2 does not have any inverse. You can find out 2 inverse also does not exist. Why 2 inverse does not exist? See, let's find out 2 inverse. What is 2 inverse? So you can see that if you see 2 inverse is not 0, because if you do multiplication modulo 4 0, then that is definitely not equal to identity element. This one is the identity element. Similarly, if I see that this 2 inverse is also not 1, because if you do 2 multiplication modulo 4 1, then that will be what? Then that will be equal to 2, and that is also not equal to identity element. That is also not equal to 1. Similarly, you can see 2 inverse is also not 2. So because if you do this, then you will get 0, which is also not identity element. Similarly, you can notice that 2 multiplication modulo 4, 3, that will be equal to 6 mod 4, and that is 2, and that is also not equal to identity element. So you can see for this 2, there is no inverse element, because 2 inverse is not this, 2 inverse is not this, 2 inverse is not this, and 2 inverse is also not 2. So there is no inverse of 2. 2 inverse is not 0, 2 inverse is not 1, 2 inverse is not 2, 2 inverse is not 3. So finally I can say that 2 inverse, it does not exist. Okay, what about the remaining 2 elements? For example, what is the 1 inverse? 1 inverse, what is the 1 inverse? Yes, this is identity element. Identity element inverse will always be identity element. We already know identity element inverse is always identity element. So yes, 1 inverse is equal to 1. What is 3 inverse? What is 3 inverse? You can check. 3 inverse will be equal to 3. 3 inverse, that will be equal to 3. So in this structure, if you see this structure, in this structure I can say that 0 inverse does not exist. Similarly, 2 inverse does not exist. 1 is identity element, 1 inverse will be 1. Identity element inverse is always identity element, and 3 inverse is equal to 3. Why 3 inverse is equal to 3? You can check it out. You can check it out. This value will be, first you multiply, then you find mod 4. So first you multiply and then you find mod 4, that will be 1, and that is your identity element. So very easily you can see that 3 inverse is equal to 3. So because these two elements do not have inverse element, okay, 0 does not have inverse, 2 does not have inverse, so I can say there is no inverse property. So what can you say about this structure? So this structure is closed. This structure is closed. This structure is associative. This also satisfies associative property because this is similar to multiplication operation. Multiplication is associative. Similarly, you can see that there is identity element also. Identity element is 1, but there is no inverse property. We have no inverse property. Also, you can see this is commutative also. This is commutative also because this is similar to multiplication. So this is commutative also. But the point is there is no inverse property. So what can you say? What is this structure? I can say that this structure is basically monoid, or I can say commutative monoid. You can say monoid, or you can simply say that this is a commutative monoid, because commutative property is satisfied because this operation is similar to multiplication. So I can say that this is a commutative monoid. This is the structure. So ultimately this structure is not group. That is the simple point. This structure is commutative monoid, but this structure is not group. So now let's see this. Can we multiply these elements of Zn? So remember, what is this structure? We have already seen the analysis of this structure. Zn, you already know Zn. Zn means 0, 1, 2 and so on, n minus 1. This is your Zn. And your operation is multiplication modulo n. First you multiply, then you find mod n. This is your operation. Now, this structure we have already seen. What is this structure? This Zn, comma multiplication modulo n. This structure we have already seen that this will be closed. The closure property will be satisfied. There is no problem. Similarly, associative property will be satisfied because this is similar to multiplication. Identity element is also there. Identity element is also there. That is 1. There is no problem. Identity element also we have. But inverse property we do not have. But we do not have inverse property. We do not have inverse property. So I can say that this structure is not group. Very simply, you can say that this structure is not group. Remember, this structure is not group. This structure is basically commutative monoid. You can say that this structure is commutative monoid. Okay, because only inverse property is the problem. In this structure, there is only one problem, that is inverse property. This structure does not have inverse property. So I can say this structure is not a group, but this structure is commutative monoid. So you can see, for example, this structure Zn, multiplication modulo n. So you can see this is your base set 0 to n minus 1. This base set, we already know that this is a group. This is a group under addition modulo n. This we already know. This set under addition modulo n. Addition modulo n. This is a group that we already know. But can we define this multiplication modulo n? Yes, we can define, but you will not get a group. The reason is simple, because inverse property is not there. For example, this element 0 does not have multiplicative inverse. Okay, this element 0, this does not have inverse. So you can simply see that this structure is not a group. Okay, now the interesting question is that how to convert this structure into a group. We know that this structure is not a group. This Zn, comma multiplication modulo n, we know that this structure is not a group. This structure is not a group. And what is the only problem? Tell me. This structure is not a group. What is the only problem? Yes, this structure is monoid. This structure is monoid, but this structure is not a group. And what is the only problem? The only problem is inverse property. The only problem is the inverse property, because some elements do not have inverse. So this inverse property is the only problem. This is the, remember this is the only problem. There is no other problem. This structure is associative. This structure is closed. Closure property satisfied, associative property satisfied, and we also have identity element. So there is no problem. The only problem is that we don't have inverse property. So now the interesting question, that is how to convert this structure into a group. We want to convert this structure into a group. How to do that? That we will understand with help of some examples. So let's start with this example. Consider this Z4 again. Let's consider this Z4 again, but under multiplication modulo 4. Under this operation. So let's consider this Z4 means 0, 1, 2, 3. This is your Z4. The operation is multiplication modulo 4. We already know. Now we want to convert this structure into a group. So how to do that? So the only problem is inverse property. There is no other problem. Closure property satisfied, associative property satisfied. Also there is identity element. This one is the identity element. But there is only one problem. That is we don't have inverse for 0, 2. You can see that this 0 inverse does not exist. This 2 inverse does not exist. This is the only problem, that we don't have inverse for these two elements. Remember, 3 inverse is 3. Also 1 inverse is 1. So the only problem is this. I can say this is the only problem, that these two elements means I can say 0, 2. These two elements, they are the problem. They do not have multiplicative inverse. See, here you can notice the operation is multiplication modulo 4. So the inverse, we are calling it multiplicative inverse. Okay, in this structure, remember, in this structure, multiplication, this operation is multiplication modulo 4. This operation, that is your multiplication modulo n. Okay, that is multiplication modulo n. So in this structure, this inverse we also call it multiplicative inverse. This inverse we also call it multiplicative inverse, because the operation is multiplication modulo 4. You can see the operation is multiplication modulo n. So the inverse is also called multiplicative inverse. This is just another name. Okay, don't worry. You can call it inverse or you can call it multiplicative inverse. Now you can see here, this is the problem, that 0 does not have multiplicative inverse. Also 2 does not have inverse. These two elements, they don't have inverse. So how to create a group? So just remove the problem. This is the problem, just remove the problem. This is the problem, remove the problem. So what you do, you remove these elements, 0, 2. You remove these elements. So what you will get? You will get 1, 3. You will get 1, 3 multiplication modulo 4. Now you cannot call it Z, you cannot call it Z4, right? We cannot call it Z4 because Z4 is 0, 1, 2, 3. This is Z4. Okay. So let's call it U4. Let's call it U4. Okay, after some time I will tell you why this is called U4, but let's call it U4. Okay, so the point is simple, that this structure is a group. This structure is a group. So let's analyze this structure. Let's analyze. So let's analyze this structure. Again, I am telling you that this is basically, we are calling it U4. Now you can see this structure is closed. You can see the closure property is satisfied. Why? You can see what is 1 multiplication modulo 4 1, that will be 1. Okay, similarly 1 multiplication modulo 4 3, that will be 3. Similarly 3 multiplication modulo 4 with 3, that will be 1, and 3 multiplication modulo 4 1, that will be 3. So again you can easily notice that this structure is closed, and this structure also satisfies associative property, because this operation is similar to multiplication. This is very similar to multiplication. First you multiply, then you find the mod 4. So this is associative also, because multiplication is associative. Next, what about the identity element? Yes, identity element is 1, because basically this is multiplication modulo 4. First you multiply, then you find mod 4. And you know, for multiplication, identity element is 1. So we have identity element also. Next, finally, now we have closure property also, because 1 inverse is 1, also 3 inverse is 3. So now we have we have inverse property also. So finally I can say this structure, look at this structure, this has closure property, this is closed, Next, this is associative, identity element is there, and every element has inverse. So inverse property also is there. So finally I can say that this structure is a group. And commutative property is also there because this is multiplication modulo 4. Multiplication is commutative. So finally actually I can say this is abelian group. So this is the simple idea. So please notice what we have done so far. Let me tell you. We started from Z4. Your Z4 is 0, 1, 2, 3. This Z4 we started. We already know that under addition modulo 4, we already know this is a group. Okay, this structure is a group. This structure is a group under addition modulo 4. But if you see the same structure, this same structure if you see under multiplication modulo 4, then that is a monoid but not group. That is a monoid but not group. Okay, and the reason why this is not a group, the reason is the only problem is inverse property, because this does not have inverse property. I can say there is no inverse property. Inverse property is not there. Some elements do not have inverse. So what we did, we wanted to convert this to group. How to convert this to group? Okay, so let's convert this to group. How to convert? So this conversion we want to do. Okay, so this is our target. See how to convert. Can I convert this into a group? So let's see how to convert into a group. So what we have done, these are the elements. These are your elements 0, 1, 2, 3. These are the elements. And under multiplication modulo 4, I want to convert this into a group. So the only problem you already know that this structure, look at this structure. In this structure, the only problem, this structure is not a group. And the only problem, what is that? The only problem is inverse property, because 0 inverse does not exist. Also 2 inverse does not exist. And this is the only problem. I can say this is the only problem. There is no other problem. Okay, so you can say that this is the only problem. This is the only issue. This is the only issue. That is the reason this is not a group. So what you do, if this is the only issue, these two elements do not have inverse. This 0, 2, they do not have inverse. They do not have multiplicative inverse. They do not have multiplicative inverse, or you can simply say that they do not have inverse. Okay, now because they do not have inverse, so how to convert them into group? Very simple. You just remove these two. Okay, you remove these two, and finally you only take those elements which have multiplicative inverse. See, 1 has inverse, 3 has inverse. So just take these. Okay, because you know that 1 inverse is 1. Also 3 inverse is 3. So 3 inverse is 3, 1 inverse is 1. So I can say these elements have inverse. This 1 has inverse, 3 has inverse. So just collect these two. Okay, these elements have inverse, just take them. Now you can see, now this structure will be a group. Now this structure will be a group. Okay, and here remember, you cannot call it Zn. You cannot call it Z4 because this is Z4. But so what should we call it? We call it U4. Okay, we call it U4. Let me tell you the reason. The reason is because we are collecting those elements which have inverse. We are collecting those elements. See, these are the elements 1, 2, 3, 4. These are the elements in Z4. In Z4, these are the elements. But in these elements, you can see that under this operation, multiplication modulo 4, under this operation, you can notice this has inverse. I can say that this has multiplicative inverse. This has multiplicative inverse. Your operation is, remember, multiplication modulo 4. This is the operation. This is your operation. Now, so this element 1 has inverse. Also, I can say that this also has inverse. This also has multiplicative inverse. So these two elements have inverse. So these two elements are called unit. Okay, these elements which have inverse under this operation 1, 3, 1, 3, these elements have inverse under this operation, under this multiplication modulo 4, under this operation. So these two elements are called unit. Okay, these two elements, they are called unit. They are called unit. Okay, so we are basically collecting the units. Remember, this does not have inverse, this does not have inverse. 0, 2, they do not have inverse. So these elements which have inverse, these are called unit. These are called unit. Now we are basically collecting the units. Now what we are doing, under this operation, I want to create a group. I want to create a group. This complete thing, I want to create a group. So what I am doing, I am collecting these units. I am collecting the units. I am collecting this 1. I am also collecting this 3. So these units I am collecting. That is the reason this is called unit group. That is the reason this is called unit group, and that is the reason we denote it by U4. This we denote by U4. Why U4? Because it is coming from Z4. This is U4 because it is coming from Z4, so it is U4. So very simple, that this is your U4. Okay, and this is a group. This is the final conclusion. I hope you understood. If you did not understand, if there is any confusion, don't worry. We will take a lot of examples. Consider this example. Z6 under multiplication modulo 6. So first of all, what is Z6? You know Z6 means 0 to 5. Z6 means 0 to 5. These are the elements in the Z6. 0, 1, 2, 3, 4, 5. 3, 4, 5. Okay. Now, we already know that this is a group under addition modulo 6. So this is group under addition modulo 6. But our operation is multiplication modulo 6. Now our operation is multiplication modulo 6. Now, under this multiplication modulo 6, this is not a group. This complete structure, if you notice, this is not a group. This structure is not a group. Why this structure is not a group? See, this structure has closure property. So closure property it also has associative property. It also has identity element. So there is no problem with these three. Closure property satisfied, associative property satisfied, and identity element is 1. So there is no problem here, because the operation is multiplication modulo 6. First you do multiplication, then you find the mod 6. Okay. So I can say these properties are satisfied. Then what is the problem? Then where is the problem? The problem is 0 inverse does not exist. Means 0 does not have inverse. Remember, 1 has inverse. Yes, 1 inverse will be 1 because 1 is identity element. Identity element inverse is always identity element. Now, so 0 does not have inverse. You can also notice that 2 also does not have inverse. You can check it out. See, 2 inverse is not 0. Similarly, 2 inverse is not 1. 2 inverse is not 2. 2 inverse is not 3. 2 inverse is not 4. 2 inverse is not 5. You can check it out. Okay, so let me check. Here, let me check in this. Let me find what is 2 inverse. So what is this 2 inverse? So let's see. First of all, you can see 2 inverse is not 0. Why? Why 2 inverse is not 0? Because if you do this, then this will not be identity element. So 2 multiplication modulo 6, okay, 0, that will be actually equal to 0. That is not identity element. Identity element is 1. Similarly, you can notice that if you see this 2 inverse is not 1, because if you do this 2 with this 1, okay, 2 multiplication modulo 6, 1, then that will be what? That will be 2. And that is again not equal to identity element. Identity element is 1. Next, you can see 2 with 2. What about 2 with 2? That will give you 4. And again you can notice that is not equal to identity element. Identity element is 1. Similarly, what about 2 with 3? If you do 2 with 3, then that will be equal to 0. Again, that is not identity element. Next, what about 2 with 4? What about 2 with 4? So 2 with 4, that will be 2. That is also not identity element. Next, 2 with 5. Finally, the last. 2 with 5. 2 with 5, that is going to give you 4. And that is also not identity element. So you can see 2 inverse does not exist. Okay, 2 inverse does not exist. 2 inverse is not 0. 2 inverse is not 1. 2 inverse is not 2. 2 inverse is not 3. 2 inverse is not 4. 2 inverse is not 5. So 2 inverse does not exist. Similarly, I leave it up to you. You can check it that 3 inverse also does not exist in this. Okay, 4 inverse also does not exist. So they do not exist. But yes, there is 5 inverse. Yes, 5 inverse is there. What is 5 inverse here? 5 inverse is 5. Okay, you can check it out. 5 inverse is a 5. Why 5 inverse is 5? You can see very easily, because 5 multiplication modulo 6, 5, that will be equal to, first you multiply, then you find mod 6. So that will be equal to 1, and that is your identity element. So I can say that 5 inverse, that is equal to 5. So 1 inverse is 1 and 5 inverse is 5. The remaining elements, they do not have inverse. This 2 inverse, this does not exist. This 2 inverse does not exist. Similarly, 3 inverse does not exist. Similarly, 4 inverse does not exist. And you can also notice that 0 inverse does not exist. You can see 0 inverse does not exist. So these elements, they do not have inverse. But I can say 1, 5, they have inverse. So what can you say about this structure? Ultimately, what can I say about this structure? This structure does not have inverse property. Again, I can say that this structure has no inverse property. Because this structure has no inverse property, so I can say this structure is basically not a group. This structure is not a group. Yes, this structure is monoid because associative, identity element and closure property are satisfied. Yes, this structure is a monoid, there is no problem. This is monoid, but this is not a group. And why this is not a group? Where is the problem? Tell me, where is the problem? Where is the problem? Where is the problem? The problem is some elements do not have inverse. For example, I can say 0, 2, 3, 4. They do not have inverse. I can say these elements, they do not have inverse. They do not have inverse under this operation. Under this operation multiplication modulo 6. Under this operation multiplication modulo 6. So you can see these elements, they do not have inverse. So this is the only problem. So how to convert this into a group? This is our target. We know the problem. The problem is that these elements do not have inverse. 0, 2, 3, 4. These do not have inverse. So how to convert this into a group? This is the next question. How to convert? So let's convert into a group. Let's convert into a group. So how to do that? Very simple. Just take those elements which have inverse. See, this element has inverse, this element has inverse. Just take those elements which have inverse. Take those elements. And I told you, these elements have inverse. These elements, they have inverse. These elements have inverse under this operation, under multiplication modulo 6. These elements have inverse. So these elements are called, these are called units. Okay, these elements are called units. So I can say this 1, 5, these are called units. This 1 is called unit and this 5 is called unit. So these are called units. That is the reason this group is called U6. U means unit. U means unit. And why this 6? This 6 is coming because of Z6. Okay, this 6 is coming because of Z6. So ultimately I can say this U6. And this U6 under multiplication modulo 6. Yes, this will be a group. This entire thing. Now you can see this entire thing will be a group. Now there is no problem. Now we also have inverse property. 1 inverse is 1 and you can see 5 inverse is 5. I hope this point is clear. Now let's move on. We will take more examples. Don't worry. A lot of examples we are going to take. So consider this next Z8. Consider this Z8. Now we already know that this Z8 under addition modulo 8. Remember, this is a group. This is actually a abelian group. This we already know. In the previous lectures, we have already seen that this is a abelian group. Okay, this addition modulo 8. This is your addition modulo 8. This is the addition. This is the addition modulo 8. So we already know that this is a group. There is no problem. Okay, this is a abelian group. But what about multiplication modulo 8? What about this operation? Under this operation, what can you say? So this Z8, first of all, what is Z8? Z8 is this. 0, 1, 2, 3, 4, 5, 6, 7. This is your Z8 and your operation is multiplication modulo 8. Now again you can see that all the properties are satisfied except inverse property. This structure, if you notice, this structure will satisfy the closure property. This structure will satisfy the associative property because multiplication is associative. This structure will satisfy identity element because identity element is 1 for multiplication. So I can say these properties are satisfied. But you can see there is no inverse property. Again you can notice there is no inverse property. Again there is no inverse property here. We don't have inverse property here. So now what to do? Tell me which elements do not have inverse. See, in this you can see, let me tell you, you can check it out. 0 inverse is not there. Next you can see 2 also does not have inverse. 4 also does not have inverse. 6 also does not have inverse. You can check it out. I leave it for you. Okay, these elements do not have inverse. These elements do not have inverse. Okay, remember the remaining elements have inverse. For example, 1 inverse. 1 is identity element. Identity element inverse is always identity element. So 1 inverse will always be 1. What is the 3 inverse? You can see 3 inverse will be actually equal to 3 inverse is 3 because you can see 3 inverse is 3 because you can see 3 multiplication modulo 8 3 that will be equal to identity element. That is equal to identity element. So I can say 3 inverse is 3. What about the 5 inverse? You can see, what about the 5 inverse? 5 inverse is also 5. You can see. Next, 7 inverse is also 7. Why 7 is inverse is 7? Because you can see 7 multiplication modulo 8. Multiplication modulo 8. 7. That is equal to 1. So first you multiply, then you find mod 8. That will be equal to 1. And 1 is the identity element. So I can say that 0, 2, 4, 6, they do not have inverse, but 1, 3, 5, 7, they have inverse. Okay, so now you tell me how to convert this structure into a group. So how to convert this structure into a group? Multiplication modulo 8. So again, just see what is the problem. The problem is inverse property, and which elements do not have inverse? So you can see 0, 2, 4, 6, they do not have inverse. So which elements have inverse? You can see here that 1, 3, 5, 7, these elements have inverse. These elements have inverse. Okay, because these elements have inverse, these elements are called unit. Okay, these elements are called unit. 1, 3, 5, 7, 1, 3, 5, 7, these elements are called, we call them are called units. These are called units. Okay, so very simple, these are called units because they have inverse. These elements, they have inverse, so we call them unit. Now if you collect these units, means 1, 3, 5, 7, if you collect these units, these are the units, we call them units. So if you collect these units, that will be a group. Now it will be a group. Now this is going to be a group, and we denote it by U8. Okay, U means unit. This U means unit, and from where this 8 is coming? 8 because of this Z8. So very simple, this U8 multiplication modulo 8, this is a group. I can say this U8 multiplication modulo 8, this structure is a group. In this structure there is inverse property. You can easily notice 1 inverse is 1, 3 inverse 3, 5 inverse 5, and 7 inverse 7. So this structure, remember, this structure is a group. So this is the idea. So this is how you can create group from this Z8. This is how you can create U8. Now let me tell you the conclusion. So far what we have seen, let me tell you the conclusion. We have seen that this Zn multiplication modulo n, we have seen that this is not a group. And the only problem is inverse property. The only problem, this is not a group. And where is the problem? The problem is inverse property. The only problem is inverse property. Some elements do not have inverse element. Okay, some elements do not have inverse. So I can say that this is the only problem. Remember, this is the only problem, inverse property. There is no other problem. Closure property satisfied, associative property satisfied, identity element is also there. But the only problem is inverse property. Now we want to convert this into a group. This structure we want to convert into a group. This structure into a group. So if you want to convert this structure into a group, then what you do? Because the only problem is inverse property, so you take all the elements which have inverse. So very simple, that this is your Zn, multiplication modulo n. Now we want to convert this into a group. Okay, into a group we want to convert. So what you do, if you want to convert into a group, we know what is the problem. Here the problem is inverse property. So what you do, you take the elements, very simple, take all elements which have inverse. Take all elements which have inverse. Okay, from here you take all the elements which have inverse. Remember, these elements which have inverse, these are called units. Okay, means take those elements which have inverse. All the elements you take which have inverse, those elements you take. These elements which have inverse, these will be called units. Okay, now if you take all the elements which have inverse, if you take those elements, then you will get a group. And this group you will say that is UN. So remember, why this UN? This UN means unit. This means unit group. Okay, this UN, that simply means unit. U means unit. Okay, and this N is coming from here. So you can see this structure will be called, this structure will be a group. In this structure, every element will have inverse. So this structure is going to be a group. So this is the final conclusion. So take all the elements which have inverse. Now the only last question is remaining, that is, how do we know which elements have inverse? Now only one last question is remaining, that is, which elements are units? Means which elements have inverse? In this Zn, which elements have inverse? Under this operation, under this multiplication modulo n, under this operation, which elements have inverse? Which elements are units? So this is the last question that we need to check. That is, which elements have inverse? Or I can say, which elements are units? So this is what we need to do. So for that we will make a final observation. This one final observation we need to make. So let's come to this question. In this question Z4 multiplication modulo 4, in this question you can notice that these two elements, they do not have inverse. You can see 0, 2, they do not have inverse. They do not have inverse. These two elements, they do not have inverse. Why these two elements do not have inverse? And remember 1, 3 have inverse. 1, 3 have inverse. In this structure 1, 3 have inverse, but 0, 2 they do not have inverse. So because these 1, 3 have inverse, so these are called units, I told you. But what is the reason? What is the reason that 1, 3 have inverse, 0, 2 does not have inverse? So this one final observation we need to make, and that is this, that see 1, 3 have inverse under this operation multiplication modulo 4. The reason is because they are co-prime to 4. See, they are co-prime to 4. These are co-prime to 4. They are relatively prime to 4. You can notice this one is relatively prime to 4. GCD of 1, 4 is 1. GCD of 3, 4 is 1. So they are relatively prime to 4. You can easily notice that GCD of 1, 4 is 1. Similarly, GCD of 3, 4 is 1. So they are relatively prime to 1. They are relatively prime to 4. This 1, 3. They are co-prime to 4. But you can notice that these elements, they are not co-prime to 4. You can easily notice. For example, if I ask you what is GCD of 2, 4, that will be 2. That will be 2. Similarly, if I ask you what is the GCD, greatest common divisor of 0, 4, that will be 4. Okay, greatest common divisor of 0, 4, what is that? Greatest common divisor. See, 4 is the greatest value which will divide both of them. You can see 4 divides 0, 4 divides 4. So you can see 4 is the greatest value that will divide both of them. Please understand, 4 is the greatest value that will divide both of them. 4 divides 0, 4 divides 4. So the greatest common divisor of 0, 4, that is 4. You can see that they are not co-prime. You can easily notice that 0, 2, they are not co-prime, or I can say relatively prime. They are not co-prime or relatively prime to 4. They are not co-prime to 4. So that is the reason they do not have inverse. So units, what are the units? Units are those elements which are co-prime to 4. Okay, now let's see this example also. So we are making this observation. In this example also you can notice which elements don't have inverse. See, 0, 2, 3, 4. These elements don't have inverse. These elements do not have inverse. These elements do not have inverse. See, why these elements do not have inverse? But remember 1, 5 have inverse. These elements have inverse. So because these elements have inverse, so I can say these elements are units. These are units. 1 is unit and 5 is unit. So these are units. But you see why these elements, why they don't have inverse? Because they are not co-prime to 6. You can see they are not co-prime to 6. They are not co-prime to 6. You can see 0 is not co-prime to 6 because GCD of 0, 6 is 6, GCD of 2, 6 is 2, GCD of 3, 6 is 3, GCD of 4, 6 is 2. So you can see these elements are not co-prime to 6. These are not co-prime to 6. But you can notice these are co-prime to 6. But you can notice that these elements are co-prime to 6. Because they are co-prime to 6, so that is the reason they are units. That is the reason they have inverse. Okay, I hope this observation is clear. Now let's see this example also, Z8. In this Z8 you can see that 0, 2, 4, 6. These elements 0, 2, 4, 6. These elements do not have inverse. Do not have inverse. These elements do not have inverse. But which elements have inverse? You can see 1, 3, 5, 7. These elements have inverse. These elements have inverse. So because these elements have inverse, so these are called units. Unit means the elements which have inverse. 1 has inverse, so 1 is unit. 3 has inverse, so 3 is unit. 5 has inverse, 5 is unit. And 7 has inverse, so 7 is unit. But you can see these elements 2, 0, 2, 4, 6, they do not have inverse. So why they do not have inverse? Why they do not have inverse? Because these elements are not co-prime with 8. These are not co-prime with 8. These are not co-prime with 8. Remember, these elements are not co-prime with 8. But you can notice these elements are co-prime with 8. these elements, they are co-prime with 8. So these elements have inverse. I hope this observation is clear. So I am just telling you that units means the elements which are co-prime with this 8. Okay, and these elements will have inverse. I hope this point is clear. So I can say, if you have this structure, remember, if you have this structure Zn, multiplication modulo n, okay, multiplication modulo n, this structure, in this structure, remember, which elements will have inverse? This structure will be closed. It is closed, closure property satisfied, associative property satisfied, and you have identity element also. So these things are there, but some elements do not have inverse. In this structure, which elements have inverse and which elements do not have inverse? So let me tell you, in this structure, let me tell you, some element m has inverse if and only if some element m has inverse. Remember, under this operation, multiplication modulo n. So remember, this element has inverse, or I can say multiplicative inverse, because the operation is multiplication. The operation is multiplication modulo n. So I can say multiplicative inverse. So I can say this element has multiplicative inverse if and only if this comma n are co-prime. This m comma n are co-prime. Okay. So if and only if m comma n are co-prime. So those elements which are co-prime to n, those elements will have inverse. And this element m we will call this m unit. Okay. Such m is called unit. Such element m is called unit. We call it unit. I hope this point is clear. So what is a unit? In this Zn, multiplication modulo n. The operation is multiplication modulo n. So in this structure, what is a unit? Unit means element having inverse. Unit means element having inverse. Inverse means multiplicative inverse, because the operation is multiplication. So I can say element having multiplicative inverse. Multiplicative inverse. Okay. And which element will have multiplicative inverse? That will be co-prime with n. That will be co-prime with n. Okay. Element which is co-prime with n. So this is what you need to understand. This is what you need to remember. Very simple point. So what is a unit? Unit is an element which have multiplicative inverse. Element which have inverse. And that is co-prime with n. These three things are same. Very simple. So if you collect all the units from this Zn, multiplication modulo n. Okay. From this, if you can remember, this is not a group. At this point, this is not a group. Because some elements don't have inverse. In this, some elements don't have inverse. But if you collect all the units from this, units means those elements which have inverse. Okay. So if you collect all the units, okay, just collect all the units, then you will get a group. If you collect all the units, then we can call it un. In this un, this u means unit. Okay, so this un, remember, this will be a group. This structure is going to be a group. This will be a abelian group, because it will be commutative, because multiplication is commutative. So you can see, just collect the units. I can say just collect all the units. Just collect all the elements which have inverse. Just collect all the elements which are co-prime to n, Collect all the elements which are co-prime with n. Collect all the elements. Then you will get a group. Then you will get an abelian group. Let's see this example. So this Z9 under multiplication modulo 9. So first of all, this is not a group. Okay, what is this Z9? Let's see. The Z9 means 0, 1, 2, 3, 4, 5, 6, 7, 8. This is your Z9. Under multiplication modulo 9. So first of all, this is not a group. This structure, this complete structure, if you notice, this complete structure is not a group. And what is the reason? The only problem, where is the problem? See, this is not a group. Yes, this is a monoid. Because associative property satisfied, closure property satisfied, and there is identity element. This is the identity element for multiplication. Okay, and this is associative. This structure is associative because multiplication is associative. So I can say that this is a monoid, but this is not a group. And where is the problem? Where do we have the problem? The problem is the inverse property. some elements don't have inverse. The problem is inverse property. This is the inverse property is the problem. So which elements don't have inverse? So in this structure, which elements don't have inverse? You can see 0 does not have inverse because 0 is not co-prime with 9. Similarly, you can notice that 3 does not have inverse. Similarly, 6 does not have inverse. These elements do not have inverse. These elements, they do not have inverse. Why they do not have inverse? The reason is simple. They do not have inverse, or I can say these are not units, or I can say these are not units. These elements are not units. These elements are not units, or I can say these elements don't have inverse. And what is the reason? The reason is simple, because they are not co-prime with 9. Because these elements are not co-prime with 9. These elements, you can check, these are not co-prime with 9. GCD of 9, 0 is 9. GCD of 3, 9 is 3. GCD of 6, 9 is 3. So you can see these are not co-prime with 9. That is the reason these elements don't have inverse. Please check it out. 3 does not have inverse. See, 3 with 0 will give you 0. That will not give you identity element. 3 with 1 will give you 3. That is also not identity element. See, you can see 3 inverse. Let's check 3 inverse. You can see 3 with 0. Okay, you can see 3 with 0, that will give you 0, and that is not identity element. You can see 3 with 1, that will give you 3. That is not identity element. Identity element is 1. Remember, this is your identity element. Your identity element is 1. Now, 3 with 2 will give you 6. That is also not identity element. 3 with 3, that will give you 0. That is also not identity element. 3 with 4, that will give you what? That will give you 3. That is also not identity element. 3 with 5, that will give you what? 3 with 5, check it out. 3 with 5 will give you 6. See, 3 with 5, that will give you 6. That is also not identity element. 3 with 7, 3 with 6. 3 with 6 will give you 0. That is also not identity element. 3 with 7 will give you 3. That is also not identity element. And 3 with 8, that will give you 6. That is also not identity element. So I am saying that 3 does not have inverse. 3 inverse does not exist. 3 inverse does not exist. I hope this point is clear. You can see 3 with 0 is not identity element. 3 with 1, not identity. 3 with 2, not identity. 3 with 3, not identity. So 3 inverse is not there. 3 with 7, that will give you what? 3 with 7, that will give you 3. That is also not identity element. So 3 inverse does not exist. Similarly, you can notice 6 inverse does not exist. And similarly, 0 inverse does not exist. These elements, they don't have inverse property. Why? These elements don't have inverse because they are not co-prime with 9. Now, which elements have inverse? Now let's check which elements are units. In this, which elements are units? Which are units? Units means elements with inverse. Okay, elements having inverse. Elements having multiplicative inverse, because the operation is multiplication. Okay, so inverse, elements having multiplicative inverse. Okay, those will be elements which are co-prime with 9. Elements which are co-prime with 9. All these things are same. Remember, units means elements with multiplicative inverse, and that is same as co-prime with 9. So which elements are co-prime with 9? 1 is co-prime with 9, 2 is co-prime with 9, 4, 4, 5 and 8. These are co-prime with 9. These elements, you can check. These elements are co-prime with 9. Also there is 7. Okay, so these elements are co-prime with 9. These are co-prime with 9. Okay, these are co-prime with 9 because you have multiplication modulo 9. So I can say these are co-prime with 9. So these are called units. These elements are called units. Now, if you collect these, then what you will get? Means what you do from this, if you want to create a group, this is not a group. This is not a group. If you want to create a group, then just collect units. Just collect the units. Okay, means you collect the units. So what you will get? These are the units, means 1, 2, 4, 5, 7, 8. These are the units. Okay, so this under multiplication modulo 9, this will be a group. This will be a group. And remember here, you are collecting the units. So this we will denote by U9. U9. U means unit. U means unit. U means unit. And this 9 is coming from here. Okay, so I can say these elements 1, 2, 4, 5, 7, 8. These elements, these are called units. So this is called unit group. This is called unit group. You can call it unit group. Okay, you can call it unit group. So this is basically U9. I hope this point is clear. I hope everything is clear so far. So this is an important point. Okay, just see the conclusion that in this Zn, you have this Zn and this multiplication modulo n, this multiplication modulo n. So in this structure, remember in this structure, what are the elements which have inverse? What are the elements? What are the elements having inverse? Elements having inverse. These elements will be called unit. These elements will be called unit. Elements having inverse, that will be called units. And that will be those elements which are co-prime with n. Remember, these elements will be co-prime with n. Co-prime with n. Okay, so these three things are same, co-prime with n. Now, this, if you collect all the units, so what is un? So remember, un means in this un, you have all the elements of Zn. You have in this un, you have all the elements of Zn which are units, which are unit. Okay, m is unit. Or I can say that in this you have all the elements of Zn. In this you have all the elements of Zn which are co-prime with n. M is co-prime with n. M is co-prime with n. Or you can simply say that this un, this is basically from 0 to, because 0 will never be co-prime with n, right? So I can say this un, it will contain from 1 to n minus 1 which are co-prime with n. Okay, so remember, in this you have those elements, which belong to 1 to n minus 1, where y is co-prime with n. Okay, so this is your un, and this is called unit group because these elements are called unit. The elements which are co-prime with n, these elements have inverse. And these elements are called units. So this is our interesting question, that how to convert Zn into a group. We want to convert Zn into a group under multiplication operation, under multiplication modulo n. So how to do that? So again, I am telling you the final conclusion. So far, whatever we have seen, I am telling you the complete summary. Please understand this. If you understand this, then everything is fine. Okay, so remember this. Okay, from the beginning, let's start. We know that Zn, first of all, what is Zn? Remember, Zn means 0 to n minus 1. You know that this is a Zn. Okay, this is the first thing, that this is Zn. Second thing, we already know that this Zn under addition modulo n, we already know this is a abelian group. This we already know from the previous lectures, that this is abelian group. Now the third thing, that this Zn under multiplication modulo n, this is not a group. This is a monoid. This is commutative also. This is commutative because this is commutative property is also there. Okay, multiplication is commutative. So I can say this is a monoid, but this is not a group. Now, what is the problem? This is not a group. See, this is not a group and the problem is inverse property. So I can say, let's see the fourth thing. So this Zn under multiplication modulo n. So this is not a group. Not a group. And why this is not a group? Every other property is satisfied. This structure, remember, this structure will satisfy associative property. Multiplication is associative. There is identity element, that is 1, and also the closure property is satisfied. So I can say this is a monoid. There is no problem. This monoid is there. But this is not a group. And where is the problem? Where do we have the problem? The problem is that some elements don't have inverse. Okay, I can say that some elements don't have inverse. Some elements don't have inverse. Under multiplication modulo n, because our operation is multiplication modulo n. So I can say that some elements don't have inverse. So this is the problem. This is the only problem that we have. So now what is the solution? Find the elements which have inverse, right? So find the elements which have inverse. In this structure, multiplication modulo n, this is the operation. In this structure, elements which have inverse. So tell me, which are the elements in this structure? Elements having inverse. Elements which have inverse. Remember, those elements which have inverse, these are called units. These are called units. And these are co-prime with n. These are co-prime with n. So these elements which have inverse, they are co-prime with n. They are co-prime with n. So these elements which are co-prime with n, these elements have inverse. Okay, and these elements we will call them units. Very simple. But the point is, these elements which are co-prime with n, these elements have inverse. So what you do, you just collect these elements. These elements have inverse, so you collect these elements, this Zn comma multiplication modulo n. From here what you do, you collect all the units. You collect all the units. Remember, units means collect those elements which are co-prime with n. Okay, so simple, that collect elements which are co-prime with n. Which are co-prime with n. So if you collect elements which are co-prime with n, then basically you are collecting the units. You are collecting the units because elements which are co-prime with n, these are called units. Okay, and these elements will have inverse. So you are collecting the units. So when you collect the units, then you will get this group un. And this un under multiplication modulo n, this will be a abelian group. This is a abelian group. So this is a abelian group. Okay, and this is also called unit group because you are collecting the units. So this is also called unit group. This is also called unit group because you are collecting the units. So very simple. So you can call it un. And in this un, remember, you have all the units, means you have all the elements which are co-prime with n. So what is un? Let's see. In direct, if I ask you directly, if I ask you what is un, then remember that will be those elements which are co-prime with n. Okay, so remember, you have those elements which are co-prime with n from 1 to n. Remember, y belongs to 1 to n. Y belongs to, 1 to n minus 1. Y belongs to 1 to n minus 1 and y is co-prime with n. Y is co-prime with n. Relatively prime with n. Y is co-prime with n. Okay, y is co-prime to n or co-prime with n. The point is that y is relatively prime to n. Okay, so this is your un. And remember, this un under multiplication modulo n, this is a abelian group. This is a abelian group. This is a abelian group. This un. And what is un? All elements which are co-prime with n from 1 to n minus 1. From 1 to n minus 1, all elements which are co-prime with n. So these elements are in un. And this is called unit group. This is called unit group. Or you can call it multiplication modulo n group. Or you can call it multiplication modulo n group. Okay, so very simple. You can call it multiplication modulo n group, or you can call it un, or you can call it unit group. So these are the different names for the same thing. So this is the complete conclusion. This is the complete summary. I hope you understood. Please pause the video and put a comment. Let me know, did you understand? The complete analysis we have seen. In the GATE exam, whatever question comes from this, you can handle it. A lot of questions can be created from this un, from this unit group. A lot of questions can be created. I hope you understood everything. I hope you understood what is unit. I hope you understood everything. What is this group? Okay, how to get this group? Everything. Okay, the complete analysis we have seen. I hope you understood. So what is un? So for each n greater than 1, what is un? Un is set of all positive integers less than n which are relatively prime to n. Okay, so this is your un. Un means, remember what is un? Un is set of all positive integers less than n which are relatively prime to n. I told you this. I told you that un means all the elements, okay, where y belongs to 1 to n minus 1. Means y is from 1 to n minus 1. And y is relatively prime to n. And y is relatively, means I can say co-prime to n. Y is relatively prime to n. Y is relatively prime to n. So this is your un. Okay, and this, remember, this un is a group under multiplication modulo n. So this point we have already seen. For example, what is U14? Let's see, U14. So what is U14? Remember, U14 means all the elements which are co-prime to 14. I can say 1 is co-prime to 14, 2 is not co-prime to 14, 3 is co-prime to 14, 4 is not co-prime to 14, 5 is co-prime to 14, 6 is not co-prime to 14. Next I can say 7 is co-prime to 14. Sorry, 7 is not co-prime to 14. 7 is not co-prime to 14 because you can see that GCD of 7 comma 14, that will be 7. So 7 is not co-prime to 14. What about 8? 8 is also not co-prime to 14 because if you see GCD of 8 comma 14, what is that? That is equal to 2. So that is also not co-prime to 14. What is 9? Yes, 9 will be co-prime to 14. 10 is not co-prime to 14. 11 is co-prime. 12 is not co-prime. Next 13 is co-prime. So this will be your U14. Remember, this will be a group under multiplication modulo 14. Under multiplication modulo 14. So this will be a group. So this is what I am saying, that U14 under multiplication, U14 under multiplication modulo 14, this is a abelian group. This is a abelian group. Okay, this is a abelian group. Now in this you can find the inverse if you want. So tell me, so this will satisfy the closure property, associative property, identity element is there. This is the identity element. So what is the inverse? For example, if I ask you what is the inverse of 1, remember identity element inverse is identity element. So this point you always understand that identity element inverse, that will always be identity element. What is inverse of 3? What is that? Inverse of 3. Inverse of 3 will be 5. Why? What is the reason? Because you can see 3 multiplication modulo 14, 5, that will be equal to 1. So because remember this, first you multiply, then you find mod 14. First you multiply, then you find mod 14. So that will be equal to 1. So inverse of 3 is equal to 5. So I can say 5 inverse is equal to 3. What about 9 inverse? What about that? 9 inverse will be 11 because you can check 9 multiplication modulo 14, 11, that will be first you multiply, then you find mod 14. So first you multiply and then you find mod 14, that will be equal to 1. So 9 inverse is 11 and 11 inverse is also 9. What about 13 inverse? 13 inverse will be 13. 30, you can check it out. 13 inverse, that will be 13. So you can see every element has inverse. So I can say this is a group. You can say this is a group, every element has an inverse. And we already know that this U14 under multiplication modulo 14, that will be a abelian group. You can just check that every element has inverse. Every element has inverse. So you can check it out. This is your U14. You can see U14 is this 1, 3, 5, 9, 11, 13. This is your U14 and this is the Kelly table of U14, or I can say this is the multiplication table of U14. You can check it out. You can find the inverse of every element you can find. Okay, and you can see this is nothing but, what is this U14? What is this U14? This is nothing but group of units in Z14. Okay, right? What is this U14? If I ask you, see how to get this U14. How do you get this U14? This U14 we get from Z14 and we collect the units, right? We collect units. From this Z14 we collect the units. Then we get the U14. So I can say U14 is basically the group of units in Z14. The group of units in Z14. Okay, I can say this is the unit group. You can call it unit group, or I can say the group of units in Z14. In this Z14, all the units you take, that is your U14. From this Z14, take all the units. That will be your Z14. So I can say this U14, this is the group of units. Group of units in Z14. So very simple. So this is the point. So I hope you can just go through this very easily. You can see. Now remember this point, that please understand that this Zn under addition modulo n is a group. Remember this point. This is the abelian group. This is the abelian group. This Zn under addition modulo n, this is the abelian group. And similarly, this Un under multiplication modulo n, this is a abelian group. Okay, this is a abelian group. So don't make this mistake. See, please understand that this is Zn under addition modulo n. This will be a abelian group. This will be a abelian group. But if you notice, this is Zn under multiplication modulo n, that will be a monoid but not group. That will be a monoid but not group. That will not be a group. Okay, and I told you that this Un under multiplication modulo n, yes, that will be a group. That will be a abelian group. Okay, so I hope this point is clear. So just make sure that you understand. See, U14 is, I can say, the operation in U14, that is multiplication mode 14, means in this UN, the operation is multiplication mode n. In this Zn, the operation is addition modulo n. Let's see this question. If P is a prime number, then what is UP? What is UP? If P is a prime number, then what is UP? Remember this point, UP means all the relatively prime, all the numbers which are less than P but relatively prime to P, right? I can say, what is UP? UP means all the numbers which are less than P from 1 to P which are relatively prime to P. Because P is a prime number, so I can say every number from 1 to P minus 1 is relatively prime to P. Okay, so UP will be 1, 2, 3 and so on, P minus 1. Okay, because remember, P is a prime number. P is a prime number. So every number from 1 to P minus 1 is relatively prime to P. I can simply say that every number from 1 to P, every number from 1 to P minus 1 is co-prime to P. Is co-prime to P. So that is the reason, remember, your UP will be 1 to P minus 1. 1, 2, 3, 4 and so on, P minus 1. This will be the UP. So for example, you can see what is UP. UP will be 1 to P minus 1. For example, what is U11? U11 will be 1, 2, 3, 4, 5, 7, 6, 8, 9, 10. Okay, so this will be U11. U11 will be from 1 to 10. This will be U11. Now, this is the summary of UN. What is UN? So you can see, if n is greater than equal to 2 is a positive integer. If n is a positive integer greater than equal to 2, then UN is equal to those elements which are relatively prime to n. Okay, those elements which are relatively prime to n. Okay, those elements which are relatively prime to n from 1 to n minus 1. Remember, 0 is never relatively prime to n. So you can just write like this. Okay, you can just simply write like this. What you can do, you can just simply say 1 to n minus 1. This is what you can do. Here, remove this 0 and you just write 1. Okay, 1. So I can say between 1 to n minus 1. Between 1 to n minus 1, which are relatively prime to n. This is your UN. For example, what is U? If n is equal to 6, then what is U6? U6 will be 1, 5. This will be U6. Okay, this is going to be U6. And remember, this U6 under multiplication modulo 6, this will be a abelian group. This is going to be a group. This is the Kelly table. You can check it out. Inverse of 1 is 1. Inverse of 5 is 5. So this is the point. Now, this we have already seen. Which element will have inverse? Which element will have inverse? So you can see element will have inverse if it is relatively prime to n. This we have already seen. Okay, we have already seen that. In this, I can say this point, if you remember, in Zn, in this Zn, M has inverse. M has multiplicative inverse. I can say M has multiplicative inverse. Okay, remember, M has multiplicative inverse if and only if M is co-prime to n. M is co-prime to n. So this we have already seen. In this Zn, M has inverse, or I can say M has multiplicative inverse if and only if M is co-prime to n. This theorem we have already seen. Okay, so very simple. So I hope these points are clear. So remember, M is unit. M is unit if and only if M is co-prime to n. Okay, so these three words are same. Again, I am telling you, unit, that is same as element having inverse. Element having multiplicative inverse. And that is same as co-prime to n. That is same as co-prime to n. Okay, so that is same as co-prime to n in Zn. Okay, so very simple. So this is what you can do. So this is everything. We have seen the complete analysis of UN. I hope you understood. So the complete analysis of UN, of this group UN, this unit group, this multiplication modulo n, this we have done. The complete analysis we have done. All the points I have told you. If in the GATE exam they ask you any question, they create any question, any variation from this, you can handle it. Please let me know in the comments. Did you understand? If you have any doubt, please ask your doubt in the comments. I will answer it. Don't hesitate. Don't keep any doubt. If you have any doubt, just ask your doubt in the comments, I will answer it.